Okay, hi Year 12. Today we're looking at 6D, the integration of trig functions. So most of our rules today are on your HSC formula sheet, but we need to know how to use them, and I guess they're not all on there as well. So there's a little bit we need to really have a little look at. Now I need you on your sheet to write this down. Basically, we might write the ones down that are in your HSC formula sheet. So I might just jump across, and you can do that to the side of your sheet over there, because the ones I've popped in for you, which look like this, are not perfect because they've got x in there instead of f of x. So we'll fix that up. Okay, so these three formulas here are the ones that are the integration of the trig functions you want to have a look at. This is how they're written on your HSC formula sheet. However, I want to think of them as a little bit different to that, because what we've got here is saying that the integration of the derivative of a function times sine of x of that function is equal to minus cos of the function. I actually want to think of it as a little bit different. So note that we have the derivative with the three of those under the integral sign. I'll jump back and show you how we want to actually think about it. So I've just written over to the right how I like to think of it and how it relates back to the formula sheet. So here we're saying that the integral of cos of a function with respect to x is 1 over the derivative of that function times sine of f of x plus c. The integral of sine of the function is going to be minus cos of the function, and we're still over the derivative of the function, plus c. And when we integrate sec squared of the function, it's 1 over the derivative of the function times tan of f of x plus c. The HSC formula sheet pops the derivative on this side. So I like to think of it over, in this case, as 1 over the derivative. So when we're integrating sine of f of x, it's minus 1 over the derivative of the function, cos of f of x. So I'm just going to be dividing in each case by the f dash of x and writing it like that. I think that's how we need to think about it, because otherwise you're probably going to be confused and not really be using the formula sheet correctly. So when we integrate sine of f of x, we look at our function, we find the derivative, we divide by it. When it's sine, it goes to minus cos, cos goes to sine, sec squared goes to tan. That's how I'd like us to have a look at it. Let's go back and look at some questions. Okay, question 1 here. Question 1 says the curve y equals sine of x is sketched below. Show that the first arch of the curve as shaded in the diagram has an area of 2 square units. So we've got the sine curve, it cuts the axes at pi. So we want to find the area under that curve between pi and 0, which we've got here on our integral of sine of x dx. So when we integrate sine, we end up with, we look over here, minus cos of the function. So I've got minus cos of the function, but I'm going to differentiate my function in here, the x, and divide by it. So it's 1, so it's not going to really need to be dealt with in this case. Let's pop pi in there. We're going to end up with minus cos of pi, here it is, minus cos of pi. So that becomes a plus in the center. Sorry, let me rephrase that again. I made a little mistake there. Minus cos of pi minus cos of 0. So that's what we end up with. Pi is 180. So you can pop that in the calculator if you like. So it becomes minus cos of pi is minus 1. Cos of 0 is 1. So we get minus 1 plus 1, which is 2 units squared. So that's a nice simple one to warm us up there. Let's have a look at the second one. Well, actually, before we do that, there's something interesting to have a look at. Did you notice above that we don't have an integral for tan? So that's something we need to have a little think about. And remembering that when we looked at logs, when we differentiate a log, we get the derivative on the function. So when we looked at the primitives of things that look like they were in the form derivative on the function, we ended up with a log. And that's what's going to happen when we look at cot and tan below. So let's have a look down below. Now, remembering what cot is. Cot is 1 on tan. Tan is sine on cos. So cot is cos on sine. So you can either work it out or you can remember that cot is cos on sine. So likewise, tan is sine on cos. So you need to know those, okay? So if I was to integrate cot of x, I would be integrating cos on sine. But what we have there, if we have our bottom line and think of that as our function, the derivative of sine is cos. So this is actually in the format, the derivative on the function. So think back up here. When something's in the form, the derivative on the function, it's log of the absolute value of that function. So in this case, because we have this in the form derivative on the function, it's log of base c of the absolute value of sine plus c. And the same thing's going to happen with our tan. We know tan of x is sine on cos, so when I integrate tan with respect to x, I'm integrating sine on cos. Now, cos is our function. The derivative of cos is minus sine. So I actually have minus log e of the absolute value of cos plus c. So we don't have that on our formula sheet, I don't think. I'm going to go and jump over and have a look. I don't use it, but it may be on ours. We'll have a look. The formula sheet. So we have on there, up further, we've got sec1 on cos, cosec1 on sine. We have cot is cos on sine. We don't have that tan is sine on cos. But if I scroll down to our next page, we've got our three integrals here in blue for sine, cos, and sec squared. We don't have tan, but we do have that if something's in the form of derivative on the function, then it's log of the absolute value of the function. So we have that, and that's what we're going to use for the integral of tan and the integral of cot as well. So let's have a look at this first example underneath that. Evaluate the following integrals. We're going to evaluate the integral between pi and 0 of cos of x. Okay, so when we're integrating cos, we're getting sine. Between pi and 0, it becomes sine of pi minus sine of 0. These ones you can pop in your calculator. Pi is 180, sine of 180 is 0, sine of 0 is 0. We end up with 0. Nice straightforward one. Okay, this one's a little bit longer. We're finding the integral between pi over 8 and 0 of sec squared of 2x plus pi. Okay, so we're between pi and over 8 and 0. So we're going to integrate sec squared. And we know when we integrate sec squared, we get tan. But we need to have a look what's in here in our brackets. We can differentiate this. And what do we end up with? We're only differentiating with respect to x here, because x is on the back here. So when we differentiate this, we get 2. So we're going to divide by that 2 and get a half. Tan of 2x plus pi between pi over 8 and 0. We are going to pop that in. So we're going to end up with a half. And I'm going to pop that out the front of the brackets because it's going to belong to both. It gives us a little bit less multiplication. Tan of 2 pi on 8 plus pi minus tan of pi, because x goes to 0 in the second one. Okay, so it's going to be tan of, I'm going to change that to pi over 4 plus pi minus tan of pi. Pi over 4 plus pi becomes 5 pi over 4. So I pop them over the same denominator. So we end up with 4 lots of pi plus 1 pi that was already there, so 5 pi over 4. Okay. You may need to work out what 5 pi over 4 is. And we could pop that in our calculator, or we could actually just go and work it out. Okay, so 5 pi over 4 is 5 times 180 over 4, which is 225 degrees. So we've got tan of 225 over there, minus tan of 180. Now tan of 180 is 0, so you can either pop that in the calculator or use your unit circle. Tan of 225 you could pop on your calculator, or you can think of your all stations to central. 225 would sit, if we're moving around, somewhere over here, and that's going to be positive anyway. So tan of 225 will be the same as tan of its smaller angle in there anyway. So we're going to end up with 1 minus 0, and it's times a half, so we're going to get a half in there for that one. Okie dokie. Now we just looked at this one above, but I've got it written in here again. Finding the primitive of the function cot x. Cot of x is cos over sine. We've got the function on the bottom. The derivative of sine is cos. The derivative is on the top, so it's a log. So it's just going to be log e of the absolute value of what we have on the bottom, which is sine of x plus c. So we're getting to be a little bit better at those now. Okay, now, like this question. Chain rule. I know we love the chain rule. So we're going to use the chain rule to differentiate cos to the power of 5 of x. Okay. Which we should be able to do by now. So cos to the power of 5 x, and I haven't popped it in there, is the same as cos of x to the power of 5. So when I've differentiated that, I've used the chain rule. 5's come down the front, down here. Cos of x is staying there, and I take 1 off that power of 5, which becomes a 4, and I multiply by the derivative inside. The derivative of cos is minus sine. So when I pop all that together, I can leave the 4 out the top of the brackets, or I can pop it back in here, which is what I've done. I'm getting minus 5 sine of x cos to the power of 4 of x. You can put cos to the power of 4 of x in front of sine of x. If you like, I generally just like to pop the sine first. Okay, now, we're going to use that because part B says, hence, find the integral between pi and 0 of sine of x cos to the power of 4 of x. We have that nearly there. So, when we differentiated cos to the 5x, we got this. So if I think of going backwards, if I now integrate my minus 5 sine to the cos to the power of 4x, I get cos of power of 5x. And I've written that down there. So I'm going to integrate the answer I got above, and I get that original question, plus c. Therefore, I'm going to use the hence part. So it's saying hence. Hence use this information we found above to solve this. So I've written my question there from above, and I can see that what I want to solve is similar. I've got sine x, I've got cos to the power of 4x. This is minus 5 times larger than this. So this must be minus 5 times larger than this. So I'm going to multiply by minus 1/5 to get it to work. So minus 1/5 of this answer between pi and 0. And I've just popped those in. This bit's fairly simple. The minus 1/5 comes out the front. I'm going to go cos to the power of 5 of pi minus cos to the power of pi, the power of 5 of 0. Cos of 180 is minus 1. You can pop that in your calculator or use a unit circle. So it's minus 1 to the power of 5. Cos of 0 is 1. So I'm taking away 1 to the power of 5. The minus 1/5 is out the front. Be careful of this. Minus 1 to the 5 is still minus 1 because it's an odd number. And I'm taking away the 1 from before, so I end up with 2/5. So I would like you to really sit down and have a practice of those because I really think that's a really great question for us to look through. Okay, lucky last question, A and B. It says, given that the first derivative, f dash of x, is sine 2 of x, and we know that f of pi is 1, we want to find the function. Nice, simple, straightforward question. So to find the function, we want to integrate our sine of 2x, or integrate f dash of x, go backwards to find f of x. If we do that, we're going to divide by the derivative of 2x, so divide by 2, so we get a half, and our sine when we integrate becomes minus cos, and the 2x stays there, but we're going to go plus c. You guys need to remember plus c. We're forgetting that a little bit, okay? F of pi is equal to 1. So if I pop pi in here where x is, and let that equal to 1, I'm going to be able to solve for c. So minus a half cos of 2 pi, that's where my x was, plus c is 1. 2 pi is 180 degrees. Cos of 180 is 1. So I get minus a half times 1 plus c is 1. Well, minus a half plus c is 1. Rearranging that to get c, we get 3 over 2. So my function becomes minus a half cos 2 pi plus 3 over 2. Part B wants me to find f of pi over 4, which is 45 degrees. So if we pop that in, we're going to get into this equation here. Minus a half cos of 2 pi on 4 plus 3 over 2. The 2 pi on 4 becomes pi over 2. It cancels down. So we get minus a half cos of 90. I like to work in degrees. Plus 3 over 2. Cos of 90 is 0. So we end up with just 3 over 2. Go and have a go at some of the exercises and let me know if you have any questions.